Starting in on our fourth lesson of the periodic table, we're going to be talking about groups and families, and specifically their names and some common things that each of them possesses. So just to start off as a reminder, groups and families are the same thing. They're all talking about the vertical columns of the periodic table. So one thing that you'll notice on your Regents reference tables is the oxidation states are always going to be listed. Okay, so these reveal the charges that ions typically form. And it's important that we start off with that because it's some commonality that we get in a lot of these groups and these families. So here are the main ones that you are going to be responsible for knowing, especially their names. Group 1, which is the first column of the periodic table, are called the alkali metals. A couple of traits that you need to know about them are that they are the most reactive metals. So even if you put them in just a small glass of water, they're going to be highly volatile and reactive. And as your reference table will show you, every one of these group 1 elements has one valence electron. Another group that you're going to be responsible for remembering is that group 2 are called alkaline earth metals. Anything that you're going to be questioned about when it comes to alkaline earth metals is going to be given by the periodic table. So you just need to know that group 2 has a specific name, and that's that name. Group 17 is on the complete other end of the table, and these are called the halogens. As far as the New York State Regents is concerned, it's one of the 2 non-metal families you need to know the name of. A couple of the key traits are that these halogens are the most reactive nonmetals. So they're the ones that are going to be most likely to have a reaction out in the real world. These group 17s can be in all phases. And when we talk all phases, I mean solid, liquid, and gas. The gases of group 17 are F and Cl. The liquids of group 17 are Br. And the solid is iodine. We're not really going to be asked about At too much on the New York State Regents. And finally, something that will be visited later on in the year is that group 17 exists as diatomic atoms or diatomic molecules, meaning they don't come as solo atoms out in the real world. They come as pairs with themselves. So these group 17s are not just F, but in the environment, it's really F2. It's not just Cl, it's Cl2, and Br2, and I2. Second to last group that we're going to need to know here is group 18. Group 18 are called the noble gases. And just like kings and queens are nobility, and nobility tends to not intermingle with the peasants in the rest of the area, in the rest of the country, noble gases don't react with anything else on the table. They are completely and utterly unreactive. The word that the Regents likes to use to trip people up about in non-reactivity is the word inert. And the word inert just simply means not reactive, right? These two things mean the same thing. Definition of inert, non-reactive. Different from halogens, noble gases don't bond to themselves. I mean, they don't bond to anything, but they specifically don't bond to themselves. So their atoms just float around as singular atoms. But the biggest thing about noble gases is the why. Why are they unreactive? And noble gases are unreactive because they have a full valence shell, which is 8, and sometimes it means 2. full valence shell is true of all noble gases, and no reactions occur once you have your full electron outer shell. This causes stability. So noble gases are stable. They don't react because of a full valence shell. The last group is group 3 through group 12. It's the weird middle section of the periodic table. There we go. The transition metals are this section of the table. And they're called transition metals because basically it's how the table transitions from one side to the other. Right? It's the connecting block. So the transition metals, there's a couple of things that you'll need to know, a couple of things that the reference table tells you, like multiple oxidation states is true of transition metals, but it's also found on your Regents exam, on your Regents periodic table. The one thing that you may be, checked on, questioned about for the Regents is which group or family tends to form colored ions when in solution. And that is only true of our group 3 through 12 area of the table. The example I like to use in class is copper. Copper ions in a solution is maybe not known to a lot of people, but copper in solution can be found in horseshoe crab blood. Horseshoe blood. Horseshoe crab blood. And the interesting thing about horseshoe crabs is that they don't have red blood. We have red blood because iron's part of our hemoglobin complex and turns, our blood slightly red. The oxygen helps and whatnot. But in a horseshoe crab, there is no iron. And what there is actually copper. And because it's a different transition metal, we get a different colored solution of blood. So, hope you enjoyed the video. If you have any questions, leave them in the comment section. And thank you for watching.